Okay, let's continue. Okay, let's have a look at what a typical Jest test can look like. Here you can see a function called getLabelByType, and it expects an object as its first and only argument. And this object should have a type property. If the value is handled by the function, as you can see here, it will return a human readable label. For example, if the type is top, then the function will return premium tier. If the type is not recognized by the function, it will simply return the type itself. And in case no argument is provided, or the provided argument does not have a type property, an error will be thrown. Okay, so now let's have a look at how this function can be tested with Jest. There are different ways how to set up Jest tests. The most common way that we use at DHIS2 as well is using describe and it functions. The describe function could cover one scenario of the code that should be tested, while the it functions will test one particular aspect of the scenario. Here you can see that the describe function expects two arguments. The first argument is a string that describes the scenario, and the second argument is a function that will contain all the individual tests of the aspects with the it function. The it function has the same structure as the describe function. So it expects a string as the first argument that describes the aspect. And normally this includes the expected outcome, as well as a condition, like it should return the premium label when the type is top. And again, the second argument is a function that will contain the actual test code. Most tests are quite simple. The actually returned value for a certain input is compared with an expected return value. Jest provides the expect function, which can be used to make assertions. In this example, you can see that the variable with the name actual contains the return value of the function when called with an object with type top. The variable expected has a static value, which is what the function should return if it worked correctly, which is premium tier in this case. The actual value is then passed to the expect function, which has some utility functions to make comparisons. In this case, the return value should be the expected value. For better readability, I created variables, the variables actual and expected, but you could just pass the values, the function call and the expected value directly to the Jest helpers, as you can see here. Okay, so another great tool that was mentioned briefly earlier is called Enzyme. It's the standard library for testing React components. And in this example, you can see that Enzyme is used to render a component here, and then check if it has both the my class name and another class name classes. The first check will return true, while the second one will obviously return false. As you can see here, this component only has the my class name class. A link to the documentation is included both in the README file that I will share later, as well as in the comments in the code sandbox environments that you will use later for the exercises. Okay, as React has introduced hooks since version 16, I think it was 16.3 or 16.8, I'm not sure. And these work different than normal functions under the hood. A specialized tool is required to test these without too much effort. One of these tools is called React Hooks Testing Library. One of the functions that this library provides is called render hook, as you can see here. It expects a function that will call the hook, as you can see here, and then return whatever the hook returns. Render hook returns an object with the result property. This is just the return value of the useRef hook, for those who are already familiar with React's hooks. That means that whatever the actual code hook returned is stored in the dot current property on this result object. In this example, you can see that the function passed to return hook just returns whatever useState, which is a hook provided by React itself, returns. So we just directly return whatever this hook returns. And when logging result.current, you can see that it contains what useState always returns, which is an array with the current value and a function to change the current value. If you're already familiar with React's context functionality, which the app runtime uses under the hood as well, you might end up with custom hooks that make use of context. And just as you would wrap an app with the app runtimes provider, you can also wrap the hook that you want to test with a component that sets up the context as shown in this example. So here you can see this is a wrapper component, which will set up the provider and a value in this case. And then when using render hook, the first argument is the function that will return whatever the hook returns. And the second argument is an object where I can just provide the wrapper. This is a short notation. This normally would look like wrapper colon wrapper. But as the key of this object has the same name as the variable, I can just write wrapper here. You can even have a wrapper that accepts properties, as you can see here. So you don't have to create a new wrapper in every test. And you can see here when I call render hook, that I can just provide the props for this test with initial props, and then this object will be the props passed to this wrapper. So you can see I provide number 42 here, and then this variable number will contain the value 42, which is then passed as the value to this provider. Okay, so now we're getting into the really advanced parts of testing React hooks. The state of that hooks return can often change over time. For example, when using the useDataQuery hook. The loading, error, and data states will change depending on the request that was made. So for example, in the beginning, loading will be true, error and data will be null. After some time, loading will be false, and error will have a value or data will have a value. And this just changes over time. To gain control over testing a hook at a certain point of time, the testing library also provides a function called act, which you can see here, which can be used to call functions returned by the hooks, like refetch, for example. The return value of render hook also contains a function called wait for next update, which, when called, returns a promise that once it fulfills, when it fulfills, then the values of the hook already have changed. But don't worry about this. This is a advanced topic already. I will include, or I have included, links to the documentation so you can read about this yourself. There's also a bonus task that you don't have to do, but I recommend you work on it just to get a feeling for this. With the async and await keywords that you can see here, that Austin already demonstrated briefly yesterday, you can just wait for the changes to have happened and then make assertions on the altered state, as you can see down here. In this example, you can see a custom hook called useCounter. And this one is being tested by this test block. This is just the it. Normally you would have this inside a describe block as well. It's just for demonstrating purposes, just like this. The initial state of the counter is 0. But it also returns a function called increment, which should increase the value of the counter by 1, as you can see here. So this will just call the internal set counter function and just increase the value by 1. With the act function, or with this one, we can then call the increment function, wait for the changes to have happened, and then we can make sure that afterwards the counter should be 1, not 0 anymore. Here you can see before we do this, we make sure that the counter is actually 0. Okay, so when you work on DHIS2 platform apps, they will include Jest. So there are no dependencies required for you to add. And if you want to run these tests, you can either just use yarn test or npm test, and it will automatically run all the tests that you have. And by default, these files need to have the .test.js or .spec.js file extension. And you can change this if you want to through the Jest configuration. Okay, so I guess now it's time for the 15 minutes break, unless someone has a question.
I was just wondering if you have any testing examples where you're making like a mock call to the API, because I know that's something that a lot of stuff will want to test, but it's not really obvious how to do in a lot of cases.
Yeah, I tried to include a mocking example in the exercises, but unfortunately, Code Sandbox does not support the mocking feature right now. It's an open issue in their GitHub, and there's an issue on Stack Overflow as well. It's one of the few features that are not supported by Code Sandbox. I do encourage you to just read the documentation of Jest. It has quite a lot of examples that you could just use to figure it out yourself. And I think the final purpose of the exercises that I will give you later is not to give you an understanding, or additionally to give you an understanding of how Jest works, to also provide familiarity with the documentation itself, because that's what you will spend a lot of time with when you write the tests.
Yeah.
There are also some examples of this in a few places in our code that we can point out maybe. But specifically, in most cases, we don't really mock we mock the API, but we don't. Our unit tests are usually not API facing, I guess.
Yes.
Okay.
We do have a tool that is, we didn't want to teach it at the moment because it's still kind of in development, but that is working on how do you mock that for functional and end-to-end testing? How do you mock the server completely? But there's also I can share a link to this for those that are interested, but it's not required for this course at all. We can also show how to use a custom data provider to basically mock out your app runtime data queries in unit tests as well. You can look at the app runtime repository itself, which has fairly extensive Jest coverage, and it uses the custom data provider to mock, basically provide a mock context for any app runtime data query calls. So I can share links to that.
Nice. Thanks,
Yes.
guys.
So when you're testing app platform apps, normally you will not do direct fetches or external requests unless you do a request to a non-DHIS2 resource. But normally you don't really deal with the direct requests. So when you test a function or a component that will eventually do a request, normally you would just, for example, if it uses the use data query hook, you can just mock for this particular test the use data query hook to return an expected return value, for example, loading through error null data null to make sure that the component behaves correctly when loading is true. Then in the next it function or describe function, depending on what you're doing, you could mock use data query to return loading false and an actual error. So you can see that your component handles errors correctly and so on. So you don't really need to mock actual data requests with the platform app that much.
Yeah, that's a good point. Thanks. Yeah.
That makes sense. So mocking the use data query hook rather than any API requests.
Yeah, exactly. I can share a link to some Jest tests as well on the Slack, on one of the Slack channels, where we're doing exactly that.
Sounds very useful. Thanks.
Okay. Are there any other questions? Okay, I guess there are no more questions. I would like to remind you to install the Chrome or Chromium browser if you don't have it installed already, as you will need that for the exercises. And after the break, I'm going to introduce you to the exercises, which are only Jest tests and will not cover Cypress. Okay, see you in a bit.